Uh, Here our question is to find the residues of z cube upon z minus 1 power 4, z minus 2, z minus 3, 8, z equal to 1. So to find the solution residues of this given function, first of all we'll find its poles. Through the help of its pole we can find its residues. So to find the poles, first of all we'll show the its denominators will be equal to 0. So through that we'll get the its required poles. So the poles are here z minus 1 power 4, z minus 2, z minus 3 equal to 0 from its denominator, which will be equal to 0. So by solving this we'll get z equal to 1 is the pole of order 4 because it has power 4. While we solve z equal minus 1 power 4 we'll get z equal to 4 ones. So that's why its order is 4. While solving this z minus 2 and z minus 3 we'll get z equal to 2 and z equal to 3, which are the simple poles. Okay, now we have to find residues 8 z equal to 1. Our question telling us to find the residues of this given function 8z equal to 1. That's why here we'll focus to find the residues at z equal to 1, not for z equal to and z equal to 3. So we know that the residues of nth order is residues at of a equal to 1 by n minus 1 factorial d power n minus 1 by d z n minus 1 d z power n minus 1 z minus residues point poles point power n of z. Okay, therefore residues we have to find at z equal to 1. That's why in the place of a we have to put 1 equal to 1 by our order is 4. N means 4 here. So 4 minus 1 factorial d n 4 minus 1 3 dz power n minus 1. N is 4 minus 1 3. At z minus a value is our 1. So z minus 1 power 4 into z cube by same f z is our given function z cube upon z minus 1 power 4, z minus 2, z minus 3 at z equal to 1, where z minus 1 power 4 and z minus 1 power 4 will be cancelled. Then 1 upon 4 minus 1 3 factorial d cube upon dz cube, z cube and remaining here upon z minus 2, z minus 3 8, z equal to 1. Then now 1 upon 6 d cube upon dz cube into z cube upon, while we multiply these two factors we'll get z square minus 5z plus 6, which is at z equal to 1. Now here we'll divide this numerator by its denominator, that is z cube by z square minus 5z plus 6. So while we dividing z cube divided by z square minus 5z plus 6, now z square z times z cube. So we'll multiply this all the divisor by this z, then we'll get here z into z square z cube minus 5z into z 5z square plus 6 into z 6z. Now subtracting, while subtracting we have to change its sign, then this plus sign change into minus, this plus minus change into plus sign, and this plus sign change into minus. Here z cube plus and minus z cube will be cancelled. Then here this change sign will look, so plus 5z square, and this changing sign is minus, so minus 6z. Again divide this one by this one. Then while we divide 5z square by z square we will get 5. Here is plus sign, so here also plus sign. Then 5 into z square, 5z square minus 5z into 5, 25z minus 25z plus 6 into 5, 30. Now here also subtract, then sign will be changed, and this become minus, this change into plus sign, and this change into minus sign. 5z square and 5z square cancel. Then minus 6z plus 25z we will get 19z minus this plus minus minus 30. Now look this first, 1 residues 8 f equal to 1 equal to 1 by 6 d cube upon dz cube. For this we divided and change in the fraction form. Then quotient is our z plus 5, so z plus 5 plus remainder is 19z minus 30, so 19z minus 30 upon our divisor is z square minus 5z plus 6. For this we can write this z minus 2 z minus 3 also, so we'll write here z minus 2 into z minus 3, which is equal to z square minus 5z plus 6, 8z equal to 1. Then 1 upon 6 d cube upon dz cube, z plus 5. Now for this do partial fraction. While we did partial fraction, it will come minus 8 upon z minus 2 plus 27 upon z minus 3, 8z equal to 1. Okay, you can check this. While we multiply this, we will get 19z minus 30 upon z minus 2 into z minus 3. Now we have to use formula here for this. Now we have to use formula for 8 upon z minus 2 and 27 upon z minus 3. There is one famous formula that we can use here. Okay, we have to use formula d power n upon d x power n into 1 upon n minus 1 equal to minus 1 power n factorial upon x minus a co power n plus 1. So then residues 8 f equal to 1 equal to 1 by 6. Here we can take minus this, while we did the derivative this 3 times, first time we will get 1 and this will be 0 because this is constant, and while we did derivative first time it will come 1, and if we did second time it will come 0, and third time also obviously 0. That's why this part will be removed from here. So remaining part is 8 upon z minus 2 and 27 upon z minus 3. So here to use this formula in this condition, here we can take minus 8 as a common and minus 1 power n. N is how many? Our derivative order power is 3. So n plus 3 into n factorial. N is 3, that's why 3 factorial upon, in the place of x we have dz, that's why z minus a. In the place of a we have 2, that's why 2, and order 3 plus 1 4 plus, and for second for 27 upon z minus 3 same process. 27 we can bring at first and minus 1 power 3 into 3 factorial upon z minus 3 ko power n plus 1. N is 3 plus 1 4, 8 z equal to 1. Now 1 upon 6, while we solve this, minus 8 into minus 1 cube, minus 1 into 3 factorial, 3 into 2 into 1 6, 6 into 8 48 minus plus 48 upon z minus 2 power 4 minus this minus, because by solving this 27 into minus 1 cube, minus 1 into 3 factorial, 3 into 2 into 1 6, 6 into 27 162 plus minus 162 upon z minus 3 power 4, 8z equal to 1. Now put the value of z equal to 1 in this question, then we'll get 1 upon 6 48 upon, in the place of z we have to put 1 minus 2 minus 1 power 4 minus, in the place of z if we put 1 minus 3 minus 2 power 4. Now 1 upon 6 48 upon 1 minus 162 upon minus 2 power 4 comes 16. While we taking LCM here 1 and 16 LCM 16, then we have to multiply this by 16, 48 into 16 minus 162. Then we'll get solving it 606 upon 16. Then we can cut this. 6 1 ja 6, 6 101 ja 606. Then we'll get 101 upon 16. So hence the required residues at z equal to 1 is 101 upon 16, which is our final solution.